Okay, day 4 of our derivatives unit. Today we're finally going to find some tangent lines. My dog's licking my face while I'm talking to you, so it's kind of hard. So let's find these two limits. Remember that we need to identify the function as that first term there. Whoa, my dog just jumped off my bed. So we're going to get the function f of x equals 6 over 5x cubed, which I'm going to write as 6x to the negative third over 5. I'm going to take the derivative of that, f prime of x, using the power rule to get negative 18x to the negative fourth over 5, which I will write as negative 18 over 5x to the fourth. Now I'm going to plug in the x value of 2 to that derivative to find f prime of 2 equals negative 18 over 5 times 2 to the fourth equals negative 18 over 5. Whew, this is complicated. 5 times 2 to the fourth is 16. Sorry, my dog was eating chocolate. I had to save her life. So we'll get negative 18 over 40, which is going to reduce to negative 9 over 20, which we cannot simplify any farther. So again, that is the derivative that we plucked out of that limit problem. We are going to do a similar problem here. Notice it's the other form of the limit this time. But our first term, wait, no, I lied, it's the same form. But here our first term is that whole mess, so f of x equals 1 plus 4x cubed over 2x. In order to take the derivative of this, we first need to split it up into 1 over 2x plus 4x cubed over 2x, which I will simplify further to x to the negative first over 2 plus 4 over 2 is 2x cubed over x is x squared. So now I can take the derivative using the power rule to get negative 1 over 2x squared plus 4x. And I can plug in my x value of negative 1 to get negative 1 over 2 times negative 1 squared plus 4 times negative 1 is negative 4.5. So negative 9 halves. Done. So we got two main goals here. We want to write the equation of tangent lines to curves at specific points by hand, and then we want to use our calculator to draw tangent lines for us. So in order to write the equation of the tangent line to this curve at this x value, we need to know two things. We need to know the point of tangency, and we need to know the slope of the tangent line. And then we will plug into our point slope form, y minus y1 equals m times x minus x1. So, in order to find the point, think about the fact that we know the x value of the point. So to find the corresponding y value, we need to plug that point into our function. So f of 3 will equal y, which is going to be 2 times 3 squared plus 5. 3 squared is 9, times 2 is 18, plus 5 is 23. So that tells me I have the point 3, 23. And now, in order to find the slope of the tangent line, I need to take the derivative f prime of x, which is going to be 4x. Power rule says multiply and drop the power. So we find our derivative, and then we need to plug in the x value we are interested in, which is 3, to get 4 times 3 equals 12. Now I have a point, and I have a slope, so I can plug into point-slope form. Y minus 23 equals 12 times x minus 3. And you're done. It is just that quick. So let's do the same thing with this problem. Again, first step, you need to rewrite this as 1 over x squared plus 4x squared over x squared, which I will rewrite as x to the negative second plus 4, because x squared over x squared, blah, 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 blah. So we need, again, a point and a slope. Let's find our point by plugging in the x value to our function, and we get 1 plus 2, whoa, my dog is going crazy. She just sat on me. 1 plus 4 times 2 squared over 2 squared will give us 17 over 4, if I'm not mistaken. So I've got my point at 2 comma 17 fourths. And I need to now find my slope, m. So I'm going to take the derivative using the power rule to get negative 2 over x cubed. And then I'm going to plug in my x value, which is, in this case, 2. So I'm going to get negative 2 over 2 cubed, which is the same as negative 1 over 2 squared, which is the same as negative 1 fourth. So I get my slope there, negative 1 fourth, and I can write my function y minus 17 fourths equals negative 1 fourth times x minus 2. Oh my goodness, doggy, calm down. So that is the gist of writing the equation of a tangent line. You should definitely also be able to get the equation in slope-intercept form. So add the 17 fourths to both sides, distribute that in, and simplify stuff. I'm pretty sure you should get y equals negative 1 fourth x. What is it? Plus 4.5? Plus 4.75, I believe. So 4 and 3/4, something like that. 19 fourths, I think. So anyways, get it into both forms, but now let's take a look at how we can do that on the calculator as well. So first thing I want you to do is I want you to do this problem by hand and then check yourself on the calculator. So take a minute, do this problem by hand. And now let's check ourselves on our calculator. Now your calculator is going to give you the equation in slope-intercept form. So if you wrote your equation in point-slope form, you're going to have to convert it. But what you should do first is graph the function f of x on the y equals screen of your calculator. So again, it would be silly to do this, to enter this like this first. You should simplify it to 2x cubed minus 3x first and enter it like that. But if you do it like this, just make sure you have parentheses in the numerator. So enter that function, 2x cubed minus 3x, and I'm graphing it on a standard window. You should get something that looks like this. Pretty gosh darn steep though. Now, once you are on the graph, you need to hit the following. So follow my keystrokes here. You are on the equation of your function like that. You need to hit the second button right there. You then, this is if you're on a TI-83 or a TI-84 that doesn't have the new operating system. You hit the second button first, and then hit the program button, which will give you the draw feature. And then you need to choose option number 5, which is to draw the tangent line. Now once you do that, it'll just plop back to your screen and look like nothing has happened. You need to now tell it the x value that you want. So type the x value of 3. It'll plop an x equals 3 down there and hit enter. Once you've done this, it will draw in the tangent line, scoobity-doobity-doo, just like that. And on the bottom, it will give you the equation. My calculator says y equals 51.000002 or something like that, x. Then it says plus negative 108 point blobbity 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 blah. It's trying to say y equals 51 x minus 108, but for whatever reason, it's not quite able to get it out. But that is how you should interpret it. Now, if you are on a TI-84, it's very similar, except you can do it in a slightly more efficient way. And by the way, you can also do it in the same exact way we just did it. And oh, wait, I lied. It doesn't matter what calculator you're on, 83 or 84. This function works the same way. Not the case for the next things I'm going to show you, but that's for a different day.